Hi everyone, and welcome to one of my answer videos, and this one is for set 4 paper 2H, which for us will be paper 11. It's a calculator paper, so make sure you use a calculator on every question where you feel you need to. You don't get any more marks if you don't use a calculator, you just make more mistakes and take more time. So please use a calculator and don't worry about anything, about using a calculator. It's really important that you show you're working out, even though you're using a calculator. That's where loads of the marks are missed, by doing too much work on the calculator and then not showing you working out. Okay, the way I want you to use this video is by looking at the questions that previously you found difficult. Starting at the beginning and working through, look at the questions that you found difficult and try and figure out how to do them using this video. The video explains all the working out of every single question. Try not to do any writing while you're watching the video. The number one thing you need is understanding. You don't lack the answers. You've got the answers in front of you. They're yours for as long as you need them. Okay, so you don't need answers. You need understanding. And the best way to get that understanding is to just concentrate on the video. Stop writing, watch the video, try and take it all in, try and understand what's happening. And then once you've watched the video, stop, or once you feel you've understood it, stop, and then you try and do it. If you need to watch the video once again, fine, no problem. Just stop writing and watch the video. But the golden rule is never write and watch the video at the same time. That is not helpful. That will not help you understand. Okay? You don't take it in and understand it as well. You're just blindly copying. Okay, let's get on with the questions. So, the first one says complete a table of values for y equals x squared plus 2x minus 3. And we're working it out and putting the answers in this table here. Now, what you can see is that you've got some symmetry in the values, and that creates this symmetrical curve. So when you've got this x squared, you're going to get what's called a parabola, a smooth curve, okay, that's symmetrical. And you can use that symmetry to check your answers. You ought to have some symmetry in your answers here. So once you've got minus 4, for example, and 2 minus 3s, you've got that symmetry. So if you work out that one to be 0, this one's going to need to be the same. And if it's not, you can use that to double check. Now, I really recommend that you work out the values for these starting with the positive numbers. So 1 squared plus 2 lots of 1 minus 3. 2 squared plus 2 lots of 2 minus 3. And I recommend, especially if you're doing it in a real exam, that you actually do that working out on paper using this space around here. Don't try and keep it all in your head. You'll make mistakes and you'll lose marks. Okay, so work this out in bits. And for the negative numbers, minus x squared. Now, one thing I just remembered, when you do this on a calculator, I really recommend actually you don't use a calculator because it's slower and you're going to make mistakes. If you put in, for example, minus 2 squared, now without a calculator, what should that be? It should be minus 2 times minus 2, which is 4. But if you do it on a calculator, it will do minus 2 squared and give you an answer of minus 4. And the reason that is because the calculator thinks that you want the negative of 2 squared. So using BODMAS, it does the 2 squared bit first of all and then makes it negative. If you want to work out minus 2 squared on a calculator, you've got to use brackets. Brackets, minus 2, close brackets, squared. And then you'll get the answer. Personally, I think it's quicker if you do it without a calculator. But take your time and show your steps and do the working out on paper. Make sure you join up the crosses with a nice smooth freehand curve. Don't join them up with straight lines because they're not lying in straight lines, and make sure you join them up. Okay, question 2 is fairly straightforward. You've got two cars. Car A uses petrol, and that's how many miles per litre car A does, and car B uses diesel, and that's how many it does. So 450, always 450 because that's a journey, divided by 10.3 because you want to find out how many lots of 10.3 goes into that so you can work out how many litres. And the answer to this part is how many litres you'll need of petrol. And each litre of petrol costs £1.39, so you multiply by that and you get the answer. Now, please, 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 when you do this, don't round it off. Keep it accurate in your calculator. Multiply it by 1.39 and then round off the final answer. Never round off an answer that's an intermediate answer. Okay, if it's not a final answer, keep it accurate. In the same way, the diesel car does 14.6 miles per litre. Okay, so every 14.6 miles needs a litre, so you divide it into 450. That's how many litres you need, multiplied by £1.47 gives you the total cost. And then finally you subtract these numbers because it asks you to find the difference in the total costs. So this is the total cost for your petrol, this is the total cost for your diesel, subtract them and you've got that. It's a pretty straightforward question. Just make sure you don't lose any marks because look, 4 marks, beautiful, lovely 4 marks for something pretty simple. Stefan is X years old and Martin is 5 years younger than Stefan. James is twice as old as Stefan. So Stefan is X, I beg your pardon. Martin is 5 years younger, so that's X take away 5. And James is twice as old as Stefan. He's X, so he is 2X. Put that into an inequality. You know the total of their age is less than 30. So Stefan and Martin and James added together is less than 30. Tidy it up. 1, 2, 3, 4 x's minus 5 is less than 30. Now you solve this equation in exactly the same way as you would do, or this inequality, I beg your pardon, in exactly the same way as you would do if it was an equation. If there was an equal sign, you do the same things. Okay, so 5 goes over, 4x is less than 35, now divide by the 4, x is 35 divided by 4, which is 8.75. Okay, he can't be 8.75 because he is a whole number of years, so the oldest he can be is 8. Okay, so Stefan's age is 8. Neville saw a car for sale. He got a discount of 25% off the price. He paid $7,200 for the car. Work out the price of the car before the discount. Now, don't find 25% of this and add it on, because it wasn't 25% of that that was taken off. It was 25% of the original price. So what you need to do is say to yourself, right, if 25% was taken off, then 75% remains. So this is 75% of the original price. So a way of thinking about that is the original price was multiplied by 0.75 to get 7,200. So you need to work backwards by dividing by 0.75, and that gives you 9,600. Another way of doing it, especially if it's on the non-calculator paper, you'd get a question like this with fairly easy numbers if you have a non-calculator paper, is you can say, right, well 7,200 is 75%. If I divide that by 3, I get 25%. Okay, and then I can either multiply that by 4 to get 100%, or add my 75 and 25% together. Whichever way I do it, I'll get the same answer, 9,600. Shabin has a biased coin. Okay, so the probability is it lands on head is 0.6. So just to make sure you understand, a biased coin, well, you know what a biased referee does in a football match. He or she favours one team over the other. Okay, in the same way, a biased coin favours one side over the other. So this one, normally it would be 50-50, but this one, the coin will land on heads is 0.6. So therefore the tails is 0.4. Shabin is going to throw the coin 3 times. She says the probability that the coin will land on tails 3 times is less than 0.1. Is Shabin correct? Well, the probability of tails is 1 take away 0.6, 0.4. And just doing that gets you a mark. Now you want tails, then and tails, 3 times on the trot. And when you're saying and, that means multiply. So 0.4 is the probability of tails, times 0.4 again, times 0.4 again. 1, 2, 3 lots of 0.4 because you want 3 tails. When you work that out, you get 0.064, which is, as Shabin says, less than 0.1. So Shabin is correct. Okay, moving on. Let's move down. Okay, question 6. A is the even numbers, B are the multiples of 3, and these are the numbers we're talking about. This is the universal set. So basically, this is the numbers. These are the numbers that we are talking about. Okay. List the members of set B. So 3, 6 and 9 is in, these are the numbers here that are multiples of 3. Find A union B, so it's all the numbers that are even or multiples of 3. Okay, so it's basically the even numbers and the multiples of 3 put together. 2, 3, 4, 6, 8, 9 and 10. 6 is in both sets, but you don't write it down twice. A intersection B is all the numbers that are even and multiples of 3. So the only number is 6. Here it says X is a member of the universal set of these numbers here. X is a member of B, or it exists in B, but it's not in A. What are the possible values of X? So it's the numbers that are in B that aren't in A. So they've got to be multiples of 3, but not even numbers. And that is 3 and 9. No 6, because it's even. X and Y are integers, that's whole numbers, such that X is bigger or equal to minus 2 and less than 3, and Y is bigger than minus 1 and less than or equal to 4. Find the values of X and Y when X equals Y. Well, the first thing to do is to write down all the values that X could be. It's got to be bigger than or equal to minus 2 and less than 3. Minus 2, minus 1, 0, 1 and 2. I'll now write down all the values that Y could be. Y's got to be bigger than minus 1 and less than or equal to 4. 0, 1, 2, 3 and 4. So what are the values when X equals Y? Well, if X can only be these numbers and Y can only be these numbers, and also X got to be equal to Y, you've got 0, you've got 1 and you've got 2. You're basically looking for the numbers that are in both sets. Keith, Ben and Liz tested a coin to find out if it was biased. They threw the coin a number of times and they counted the number of heads and the number of tails they each got. Which person, Keith, Ben or Liz, will have the best estimate? Now when you're doing an experiment, your estimates become more reliable the more times you do it. Okay, so if you did a survey, so for example, of 10 people, your results won't be as reliable generally as if you interviewed 100 people. And same thing when you're doing the experiment. Okay, so Liz's results will be more reliable because she's done the experiment more times. Say hello to a nice, free, easy 1 mark. Using all the results in the table, work out an estimate for the probability that the next row of the coin will be a head. So the total number of times you did it, you add up all the heads, you add up all the tails, and then you total it and you get 440. So that's the total number of times the experiment was conducted. And you got a head 103 times. So your estimate for the probability is 103 out of 440. And you can write that as a decimal or a percentage, but that fraction is fine. ABC is a triangle. D is a point on AB. And E is a point on AC. DE is parallel to BC. And we've got this information which we can also see on here. Calculate the perimeter of the trapezium DBCE. Now, it's not asking you to calculate an area of a trapezium, just the perimeter. So we need to know what the lengths are. And the way in, and the thing that should give you a clue, is that we've got these 2 parallel lines here, and we've got a triangle inside a triangle. And that tells you that these 2 triangles are similar. Now, how do we know that? Well, if these 2 lines are parallel, we've got F angles, and that is the same as that. So those 2 angles are the same. For the same reason, that angle and that angle are the same. And this angle is inside both the small triangle and the large triangle. So this triangle has got the same angles as this triangle. And therefore, it's the same shape, but it's just a smaller version, or this is a larger version. So both the triangles, or the triangles, are similar to each other. So what we need to do is work out what the missing lengths are. And the way we do that is by comparing a pair of corresponding sides, they'll always give us a pair, and working out what the scale factor is. So if I look at this side here, that's 4, and the corresponding side on the big triangle is this, and that is 6 add 4, which is 10. So if that is 10 and that is 4, 10 divided by 4 gives me 2.5. So that's telling me that this side, or this length, is 2.5 times longer than this. Now the whole idea about similarity means that this will be 2.5 times bigger than this, and this will be 2.5 times bigger than this. So we can now use that scale factor to work out the missing sides. This will be 14.5, multiply that by 2.5, and this will be 12.5 because it's 5 times 2.5. Okay, so now we know what the lengths of the triangle of the trapezium are. We've got this down here, which is 12.5. This was given to us, that's 6. That's given to us, that's 5. And this is the difference between the 14.5 that we worked out for that and 5.8. So subtracting those gives you 8.7. Adding up those sides gives you the perimeter of the trapezium. So it's not about finding the area of a trapezium or anything really to do with trapeziums. Think of it as the difference between these two triangles. Joe and Anne buy some fruit from the same shop. Joe buys 4 apples and 3 bananas for £2.50, and Anne buys 3 apples and 4 bananas for £2.40. Work out the cost of 1 apple and 1 banana. So what we need to do in a situation like this is we need to have the same amount of apples or the same amount of bananas in both orders. And we do that, if it's not already done, by multiplying one or both orders. So you can see here that the teacher has decided to multiply everything here by 3. 3 lots of that, add 3 lots of that is going to be 3 lots of that. And multiply everything here by 4. 4 lots of that, 4 lots of that, and 4 lots of that. And that gives us 12 apples and 9 bananas equals £7.50, and 12 apples plus 16 bananas gives us £9.60. Okay? Now, the reason we've done that is because by doing this multiplication, we've got the same number of apples. And so therefore we know that any difference in price is because we've got a different number of bananas. Take that away from that and you get 7 bananas. Take that away from that and you get £2.10. So 7 bananas must be £2.10, so 1 banana is 30. Take that price of B being 30 and substitute it in one of the equations, whichever one looks easiest. Okay, take the top one, you could take the bottom one, could take that one, but the teacher's taken this one. 4 apples plus 3 bananas is £2.50, but we know that now a banana is 30 pence. So 4 apples plus 3 lots of 30, that's 90 pence, is £2.50. Take the 90 away from the £2.50 and you've got 4 apples equals £1.60. So 1 apple is £1.60 divided by 4, 0.4. So now we know that an apple is 40 and a banana is 30. Just in case you were wondering, you could have multiplied this by 4 and this by 3, and that would have given you 12 bananas in both orders. And once again, you could have subtracted. That's a perfectly good way of doing it. Okay, it's just a different way. Okay, each way is perfectly fine. Gail invests in an account that pays compound interest of 5% per annum. How many years does it take to double the money in her investment? Now, every time you're going to, every year, I beg your pardon, your money is going to grow by 5. And the multiplier for a 5% increase is 1.05. The 1 is the bit you've got already, and the 0.05 is the 5% you're adding on. So if you did this for 2 years, it would be 100 times 1.05 to the power of 2. For 10 years, 100 times 1.05 to the power of 10, because every year it gets multiplied by 1.05. And you want to know how many years would it take to make this number go over 200. Now you can try it with guesswork, or you could just simply start off with 100, multiply it by 1.05, keep it in your calculator, multiply that by 1.05, keep it in your calculator, multiply that by 1.05. If I was you, I'd write it down as you go, otherwise you'll lose count. And just keep on going until you go over 200. You should find it's 15. Okay. So if you try that with 15, it will be over 200, and if you try that with 14, it will be slightly under 200. So it's going to take 15 years to make this grow to 200. Question 12. There are only 4 mint biscuits and 1 toffee biscuit in a tin, and there are only 5 mint sweets and 3 strawberry sweets in a packet. Michael's mum lets him take 1 biscuit from the tin and 1 sweet from the packet. Michael takes a biscuit at random from the tin, and he also takes a sweet at random from the packet. And you can see that Michael and his mum have an absolute scream at home, don't they? Michael's taking biscuits at random and sweets at random. He knows how to spice up his life. He's having an epic time, and his mum's supporting him all the way. It's brilliant. Anyway, back to the real world. What's happening here? We need to work out what the probability of getting a biscuit and the sweets are. So look at this one here. 4 mint biscuits, 1 toffee biscuit. So the probability of mint is 4 out of 5. Probability of toffee, 1 out of 5. With the sweets, the probability of mint is 5 out of 8. And the probability of strawberry is 3 out of 8. Now you could solve it doing a tree diagram. Okay, but if you know what you're doing, you don't need to. How can you get either the biscuit is mint or the sweet is mint, but not both? So what you want is a mint biscuit with a not mint sweet, or a not mint biscuit and a mint sweet. So you want mint biscuit and, that means multiply, a not mint sweet. So you multiply the probabilities that you've worked up here, choosing the right ones. So probability of mint is 4 out of 5. Probability of a not mint or strawberry sweet is 3 out of 8. Multiply that together. 4 times 3, 12. 5 times 8, 40. Or you could have the biscuit that's not mint and the sweet that's mint. So the probability that the biscuit's not mint is the toffee biscuit, that's 1 out of 5. And then you want the mint sweet, which is 5 out of 8. Multiply that again. 1 times 5, 5. 5 times 8, 40. Okay, so you can get one mint but not the other different ways. This way or this way. And when you say or, you add those probabilities together. So 12 out of 40, add 5 out of 40, gives you a total of 17 out of 40. The diagram gives information about 2 paintings A and B. Each painting is in the shape of a rectangle. Painting A has an area 1,725 square centimeters bigger than the area of painting B. Now be careful here, it didn't say it's got an area 1,725 times bigger. It just means that this has got an extra 1,725 square centimeters area. So whatever that is, if you add on 1,725, you'll get that. So first of all, let's write that out as an equation. Well, what's the area of this? It's a rectangle, and it's length times height. So it's 35 times x plus 20. That's your area of painting B. This is your area of painting A. 50 times 2x minus 10. And we're told that this area is the same as this area plus 1,725. So that's your starting equation, and look, you've got a mark just for doing that. Now let's solve it. So get rid of the brackets. 50 times 2x is 100x. Don't forget the 50 times 10 minus 500 equals 35 times x is 35x, and 35 times 20 is 700. Add the 1,725. Now let's simplify. We've got 35 over to here gives you 65x. The minus 500 will hop over to here, and you get an equation of 65x equals 2,925. Okay, so we've added those together, and then we subtracted the 500. Beg your pardon, we've added the 500. Okay. Now, 65x is 2,925, so to get one lot of x, we divide by 65 and we get 45. So that is the value of x. Now, be careful because we haven't finished yet. We picked up some marks, but it actually said work out the area of painting A. Well, we've just worked out that x is 45, so 2 lots of x would be 90, take away 10 is 80, and then 80 times 50 gives us 4,000. So the area of the rectangle painting A is 4,000 square centimeters. Question 14. The average fuel consumption of a car is given by the formula C equals D over F. Now D is 190 correct to 3 significant figures, and F is 25.7 correct to 1 decimal place. So what we need to do is work out the upper and the lower bound of each of those numbers. Now D is written to 3 significant figures. That means that we're going to either write the number as 190, or 191, or 189, and so on. Now if a number has been written to 190 correct to 3 significant figures, what you do is you go halfway between the next number up and the next number down. So for example, 190, then 191. Halfway between that is 190.5. That's the biggest that D could possibly be. If it was any bigger, it would be 191. In the same way, halfway between 190 and 189 is 189.5, and that's called the lower bound. So because we've written this to 3 significant figures, even though we're writing it as 190, what we're saying is it could actually be as small as 189.5 and as big as 190.5. In the same way, 25.7 correct to 1 decimal place. Well, if you were writing numbers to 1 decimal place, after 25.7 you'd have 25.8, and before 25.7 you'd have 25.6. And once again, you find the halfway mark between those two numbers. So between 25.7 and 25.8 is 25.75. And between 25.7 and 25.6 is 25.65. So what we're saying is, even though we've written the number 25.7 correct to 1 decimal place, even though we're writing it as 25.7, it could actually be as small as 25.65 and as large as 25.75. Okay, so that is the upper and lower bounds of that, and this is the upper and lower bounds of that we just spoke about. So what are the values of C? What's the biggest it could possibly be? Well, we're taking D and we're dividing it by F. So to get the biggest possible value that C could be, you divide the biggest that this could be by the smallest that could be. So it goes into that as many times as possible. Okay, and here the teacher's made a slight mistake. Even though they've written that correctly, they made a little bit of a boo-boo here. That should actually be 25.65. Okay, so these numbers need to be swapped. Okay. And to make this number as small as possible, you want this number as small as possible and this number as big as possible. So that should be 189.5 divided by 25.75. Okay. Now, I don't think these numbers here are quite what you should get, because these are the answers to the calculation the teachers put down. So once again, you should have 190.5 divided by 25.65. And this one needs to be 189.5 divided by 25.75. What you should notice is that this answer, I think, is about 7.4 something, and this answer is about 7.3 something, but both of them round to 7.4 to 1 decimal place. Okay, so the answer is, as a sensible degree of accuracy, is 7.4, because it's after 1 decimal place of rounding that the answers agree. Okay. And we can't be any more, it means basically that we can't be any more accurate than 1 decimal place. Okay, here what we're doing is we're trying to find an approximation for the area under this curve. So there's not a formula to work out the area, so we're going to need to cut this into bits. And we do this by drawing vertical lines up from here, and then when it hits the curve, joining them up. So we get a triangle, and then we get this bit here is a trapezium up to there and then down. Okay, and this will also be a trapezium, and so on. Okay, and the way to find it is, this is a triangle, so it's going to be half base times height, so that's going to be 5 times 1, half of that is 2.5. What's the area of this trapezium? Well, the base is 1, or the height of the trapezium, because it's laying on its side, is 1. The bottom is about 8, and the top is about 6 or 5. Yeah, about 5. Okay, so then you use that half of the top plus bottom times the height. Okay, and you work out those answers, and then you double it because we just done this part here, and then you can double it to get the other side. So what we need to do really here is draw in some lines. Obviously I can see that the teacher's done this, but it hasn't quite come out in the photocopying. So draw lines from here up to the curve, okay, and then join them up to get a trapeziums. We get a triangle and 1, 2 trapeziums, and these ones will be the same. So just work out this side and double it. Okay, the trapezium's lying on its side. If we turned it 90 degrees, this would be the bottom of the trapezium, this would be the top of the trapezium, and this would be the height of the trapezium. And to work out the area of a trapezium, it's the average of the top and the bottom times by the height. Okay. Question 16. The number of rabbits on a farm n months from now is Rn, where R0 is 200 and Rn plus 1 equals 1.2 Rn minus 35. Now we haven't done this before, but it's actually fairly simple, because basically what this is saying to us is the next value of R is worked out by the previous value of R multiplied by 1.2 and then subtract 35. So R0 is 200. R1 will be 1.2 times 200, take away 35, which is 205. And then you take R1 and you put it in this formula, and it works out R2. And then you take that R2 and put it in that formula, and it works out R3. And there we go. Here's your answer. Okay, show the steps and pick up some marks. Question 17. In the triangle XYZ, XY is 8.7, YZ is 11.6, and the angle is 52. Now, it's asking us to work out the area of this triangle. Now, whenever you see a triangle with an angle and the sides either side, that is your half AB sine C formula. So the AB are the two sides, either side of the angle, and the C, the sine C, is this. So it's literally half of 11.6 times 8.7 times the sine of 52. And that's your formula, and you get the answer. Now, let's imagine you couldn't do that. You couldn't remember what that formula was. Well, how else do you find the area of a triangle? Half base times height. And so, what is this height? Well, drop the height down, and you've got a right angled triangle. And this is the opposite in the triangle if that's the angle we're talking about. If that is the opposite, you can work it out by 8.7 times the sine of 52. Okay? And then half it times the base. Basically, it's the same thing. It's just that that process has been put into a formula, half AB sine C. But it's actually the same thing, because this is that sine C. Okay? And then you're going to do half that times that to get the area. So actually, you're doing the same thing. Okay? So if you can't remember the formula, just do it in bits using the old basic trigonometry. Then it asks us to work out what XZ is. Once again, when you've got two sides and an angle in between, and you've worked out an opposite side, that's telling you it's a cosine rule question. So, here's your formula. A squared equals B squared plus C squared minus 2BC cos A. So, work it out. Okay, 11.6 squared plus 8.7 squared minus 2 lots of 11.6 times 8.7 times the cos of 52. Okay, work all that out on the calculator. Don't forget it's squared, so just like Pythagoras, you square root that answer to work out what the final number is. Okay, always have a quick double check. If that's 11.6 and that's 8.7, that is no way going to be 85. Why isn't it 85.98? Because you haven't square rooted it yet. This is XZ squared. Okay. Okay, so first of all, we've got to work out some points here. In the diagram, ABC is the line with the equation y equals minus half x plus 5. Now, look out, because we've got two lines crossing, and often they say it's perpendicular, but this time it hasn't. Hasn't said anything about perpendicular at all. They're not perpendicular. Okay, so we've got to work out the equation of this line. So what we need to do is we need to work out the coordinate of this point here. This one we're told already is minus 13, 0. If we know what the coordinate of that point is, we can join it up and work out the equation. So what do we know? Well, this line has got an equation of y equals half x minus half x, add 5. So what is the value of x and y here? Well, you can see that y is 0. And if y is 0, it must mean that x is 10. Because half of 10 is 5. So minus half of 10 is minus 5. Added to the 5 makes 0. So 10 is the value that x needs to be to make this expression, and therefore y equals 0. So that is 10, 0. What's the value of this? Well, x is 0, and it crosses the y-intercept, and that can be found by this number at the end of the equation, plus 5. So the value or the coordinate of this point is 0, 5. Once again, you've got some marks just for doing that. Now we need to work out what the coordinate of this is. Well, what we know is this is the midpoint of this line. So let's think about this. We go back 10 and we go up 5. So the journey from here to here will be the same. Go back 10, so that's minus 10, up 5, 5. So the coordinate of A is going to be, whoops, I made a mistake. Once again, go back 10 and go up 5. Go back 10, which is minus 10, and then go up 5. So it's 10, not 5. Okay, so this is halfway along the journey, and you're 5 up. So the whole way along the journey, you'll be 10 up. This is 10, so that will be 10. So the coordinate of this point here is minus 10 plus 10. Okay, which is what you've got here. So now we've got 2 points. Okay, we've got this point here, minus 10, 10, and this point here, minus 13, 0. Let's work out the gradient. It must be from here to here. Well, here we're at minus 13, and here we're at minus 10. So this distance is 3. Okay, this distance is 0 up to 10, so this here is 10. So the gradient is our up number, 10, divided by the along number, which is 3. And we're going to leave that as a fraction. Don't be tempted to make it into a decimal. Leave it as 10 over 3. Right, what else do we know? Well, we know that this line, if that's the gradient, the equation is going to be y equals 10 over 3x, because this number is always the gradient, plus c. Alright, what else do we know? We know that the line goes through the point minus 13, 0. And that means that when x is minus 13, y is 0. So, when x is minus 13, y is 0. Okay, so 10 times minus 13 is minus 130 over 3. Okay, and therefore c must be 130 over 3. Okay, to make that answer 0. So now we've worked out the gradient and the c number, we've got our equation. Y equals 10 over 3x plus 130 over 3. H is inversely proportional to the square of r. So what that means is inversely proportional means 1 over. Okay, square of r is r squared. So we write h is proportional to 1 over r squared. And then we simply change that proportional sign to an equal sign and put a k there. We're saying basically this means that h is some amount of r over r squared, and we need to find out what this number is. The way we do that is because the question will always give us r and h at the same time. So we know that when h is 3.4, r is 5. Work that out. 5 squared is 25. And we can use this now to work out that k is 25 times 3.4, which is 85. So we've used this information to work out that k is 85, and now we've got an equation, or beg your pardon, a formula, that says h is 85 over r squared. So the k is now 85. We worked it out. Here's our formula. And then it says find the value of h when r is 8. So we put 8 in here. 8 squared is 64. 85 divided by 64 is 1.32. Okay, so h is that answer there. Okay, in question 20, we've got this equation with some algebra stuff on the bottom. And the way the teacher's done that is to get rid of each of these denominators in turn. So the first thing she's done is multiply everything here and here and here by x plus 3, because that's the denominator here. Multiplying this by x plus 3 will wipe out the x plus 3 on the bottom, leaving you just with 4. 3 lots of x plus 3 and 1 lot of x plus 3. So we get this equation here. So we've got rid of this part. Now we're going to multiply that and that and that by 2x minus 1. So multiply that by 2x minus 1, you get 4 lots of 2x minus 1. Multiply this by 2x minus 1 and you wipe out that one at the bottom. Okay, because you're timesing by 2x minus 1 and dividing by 2x minus 1, so they wipe each other out, and that leaves you with just 3 lots of x plus 3, the numerator here, equals x plus 3 times 2x minus 1. So each of these things has been multiplied by 2x minus 1. Now get rid of the brackets. 4 lots of 2x minus 1 is 8x minus 4. 3 lots of x plus 3 is 3x plus 9. Multiplying these brackets out gives you this. Okay, tidy it all up. Tidy the left hand side up, tidy the right hand side up, and you get this. Take this stuff now over to here. Okay, it becomes minus 11x. Take this 5 over here, it becomes minus 5. To give you a quadratic equation that equals 0, because when we're solving these quadratic equations, we need them to be equal to 0. We've got 2x squared minus 6x minus 8 equals 0. Well, we can see that both these numbers, or all three of these numbers, are even. So we can make it more simple by just dividing everything by 0. Okay? Because if it's equal to 0, when you halve it, it will still be equal to 0. So half of 2x is x squared. Half of minus 6x is minus 3x, and half of minus 8 is minus 4. And this now factorizes quite nicely. You don't need an equation, don't need that formula, don't need anything really heavy duty. Okay, just factorize it. Okay, we're looking for two numbers that multiply to make minus 4 and add to make minus 3, and that's going to be minus 4 and 1, which gives you the answer there. Okay, so x is going to be either 4 to make that answer 0, or minus 1 to make that answer 0. Because remember, the way we do it is we've got two brackets here that are being multiplied together to make an answer of 0. And when you've got two numbers multiplied together to make 0, either, well, one of them must be 0. So if these two things are multiplied together to make 0, either this is 0, which means that x must be 4, or that must be 0, which means that x is minus 1. Okay. Right, let's look at question 21. Okay, so last question, we've got question 21. It says the histogram gives information about the speeds in kilometers per hour of some cars on a road. Work out an estimate for the median speed. Give your answer correct to one decimal place. You must show you're working. So the median is the halfway mark. So what we need to do, first of all, is work out how many cars this histogram represents. Now, the difficulty with this particular question is we don't know what the scale is here. Now, for this particular question, because it's the last question, I don't expect you to completely get this, but actually it doesn't matter what the scale is. It won't actually affect the numbers that are in the middle. Okay, so just make up a scale for this particular question. If there isn't a scale, make it up. So we've started off with 1, 2, 3, 4, 5. Now remember that for histograms, it's the area of the bars that represent the number, not the height. So now we've got the width of the bar. This, for example, is 2.5. and we use this scale to work out the height of each of the bars, and then multiplying the height by the width gives us the numbers inside. So this one, for example, is 5, and that's 2.5, so that's 7.5, and the height is going to be 4.7, okay, and so on. You can work out the areas of these bars. So just doing that gets you some marks. Now, and by the way, you can see that the teacher's done that. 5 times 2.8, 15 times 0.7, and so on. Okay, so these are the calculations. Okay, one number is the width and one number is the height. Okay, that gives you the areas and therefore the numbers of cars in each bars. You add that together and you get 69.25. Now, because it's a continuous measure, you can just simply half that. So you don't need to do the add 1 and half it, just half it. So we need to know half of the area, half of the number of people. So half of that gives me 34.625. And we want to work out how far along here an area of 34.625 comes to. So we need to work through these bars. Now, whoops. Well, the first part of the bar is 9. Okay, so we take that away and that leaves us with 25.125. So that number lies inside here because we've got 35.25, and so 25.125 comes in here somewhere. So basically we need to know, okay, if it's going to be 4.7 high, how wide does it need to be to make an area of 25.125? And the way we do that is say, right, okay, 25.125 out of 35.25, that's the area of that bar, gives me 0.7. So basically what we're saying is that this number is about 7/10 of this number. Okay, and therefore it's going to be about 7/10 of the width to make the area that 25.12. If the height is staying the same, we need about 7/10, 0.7 of the width. Now the whole width is 7.5, so we want to multiply that 7.5 by 5.3. So basically what we're saying is this: if the area of the bar was 25.125, it would have to be 5.34 wide. Okay, now up to here we're at 55, and if we're going to go along 5.345, we need to add that number onto the 55 to give me 60.3457. So my estimate to one decimal place is 60.3 as the median. Now it's an estimate, okay, because we don't know how the cars are spread out. More may be here than here in reality. That's why it's an estimate, okay, but that's how you would go about doing a question like this. Okay, I hope this video was really helpful to you. I know some of the questions near the end are pretty nasty, okay, but if you can do all of them up to, well, if you can do up to question 18, you're doing absolutely fantastic. And you know, in some of these you can pick up marks here and there. Earlier on, I hope you found the video helpful, but please, 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 if you didn't, if there's a particular question which after spotting my video is still no help to you, then please ask me. Okay, don't sit back and think, you know, that you can't ask. Of course you can. Ask me. I really want to help you guys. Okay, cheers. Thank you. Bye.